Bismillahirrahmanirrahim. Dear student, welcome to Ad-Din Women's Medical College Phase 1 online teaching program. Assalamu alaikum. Today topics is the continuation of my previous topics. Now come to the whiteboard. As I discussed previously, that is arterial filtration pressure is 13 and venous reabsorption pressure is 7. How is it possible to reabsorb all the fluid that is filtered in the arterial end and reabsorbed from the venous end? 13 millimeter of mercury in arterial end and 7 millimeter of mercury in venous end. Is it possible? Yes, it is possible because the venous capillaries is larger and venous capillary permeability is more. Now come to the main topics. About 100 years before, Starling he showed that filtration and reabsorption is almost equal. Then he made an equilibrium that is called Starling equilibrium for capillary exchange. Now you can calculate the Starling equilibrium, that is mean force tending to move fluid outward. What are the forces that fluid moves outwards? One is mean capillary pressure is 17.3, but here you have seen the arterial end of the distributor is 30 and venous end is the 10. But Starling his mean average capillary pressure is 17.3. Then other two pressure is same. One is negative interstitial fluid pressure is 3 millimeter of mercury. Another interstitial fluid colloid osmotic pressure is 28 millimeter of mercury. This total summation is 28.3 millimeter of mercury. This is the outward force. Then again the inward force, same, the mean force tending to move fluid inwards. Plasma colloid osmotic pressure is 28 millimeter of mercury. How much the difference? Only the outward force is 28.3 millimeter of mercury and inward force is 28 millimeter of mercury. How much the difference? Difference is 0.3 millimeter of mercury. Now this 0.3 millimeter of mercury causes 2 milliliter of fluid per minute per 0.3 millimeter of mercury per whole body. That is, it means this is called filtration coefficient. That is 2 milliliter per minute per 0.3 millimeter of mercury per whole body. But if you convert in 1 millimeter of mercury, it is 6.67 milliliter. But the filtration coefficient is sometimes expressed in 100 gram of tissue. 100 gram of tissue. If you convert this, the 100 gram of tissue, it is 0.01 ml per minute per millimeter of mercury per 100 gram of tissue. In whole of the body is same things, but in kidney it is 4.2 ml per minute per millimeter of mercury per 100 gram of tissue. That is kidney. That is called filtration coefficient. That is called filtration coefficient. What is filtration coefficient? It is the fluid that is filtered in ml per minute per millimeter of mercury pressure per 100 gram of tissue. That is every minute how much fluid is filtered? Filtration is 2 ml. In 1 hour how much? 120 ml. From these 120 ml, 100 ml goes to circulation through the lymphatics. Which lymphatics? Thoracic duct, thoracic duct. And remaining 20 ml goes to the again circulation through the another lymphatics. The thoracic duct not only carries the interstitial fluid, also it will transport colloid as well as lipid from the intestine. Which lipid? And chylomicron. These thoracic duct drain in the vein. These are at the junction of the left subclavian vein and left internal jugular vein. Right lymphatic ducts drain on the right subclavian vein, and the right internal jugular vein. How much fluid will produce in one day? In 1 minute it is 2 ml. In 60 minutes it is 120 ml. In one day it is about 3 liters. If this fluid is not drained into the circulation, the human being would die within 24 hours. Now come to the some pressure that increase the lymphatic form. What are the pressure to form the lymphatic form? Elevated capillary hydrostatic pressure, decreased colloidal osmotic pressure, plasma colloid osmotic pressure, increased interstitial fluid colloid osmotic pressure, and increased capillary permeability. These 4 cause the increased lymph formation or increased interstitial fluid formation. How this lymphatic drainage will be pumped? Lymphatic drainage will be pumped by several mechanisms. What are the mechanisms? One is compression of the skeletal muscle surround the lymphatics. 2 is movement of different parts of the body, that it elevate the lymphatic drainage. Then arterial pulsation adjacent to the lymphatics, that also increase the lymphatic pump. Then compression of the tissue by compressed by object outside the body. That is compression of the tissue by object outside the body. These 4 factors increase the lymphatic drain. Now, another thing is very important things is how this negative pressure, negative interstitial fluid pressure is 3. How it is developed? It is developed due to the continuous suction of the lymphatic. The importance of or significance of negative pressure. In most of the body it is the negative pressure, but in some place it is a positive pressure. Where the positive pressure? In the brain and kidney, but other place it is the negative pressure. The importance of negative pressure is it acts as a vacuum. That is, in some place there is no connective tissue or connective tissue is very weak, then tissue are not hold together. These negative pressure hold the tissue together. Suppose in the dorsum of the hand is skin and skin on the face.